This is practical number 11, analysis of 2 Cube Factorial experiments in RBD, partial confounding, part 2. This is the first example. We are having analyze the following data. Replicate 1, we are having this 2 blocks, replicate 2 having 2 blocks, replicate 3 having 2 blocks here. In the previous practical we are having 4 replicates. Here in this practical we are having 3 replicates. So what we have to do here, what is the difference only here? We have to perform the same way, only the minor changes that we have to have here. So how many observations because of this? 8 observation in one replicate. So 3 replicates. So we are having in all 24 observations here. So once again we'll find out the totals here, treatment totals we'll find out. Related to 1 we are having in replication 1 it is 75 value that will pick from this. Similarly 108 from replicate 2 and 77 from replicate 3 that we are having, and we have used this values and we got this for all the treatment combination. So we got the totals from all the replicates for all the treatment combinations. Then we find out the Yates table, once again prepared by our usual way. Follow the order of this treatment combinations. Write this treatment totals what we have obtained in the previous case. Do this here. This half part is addition of this 2, this 2, this 2, this 2. This way we are having this, and in the second half part we do the subtraction here. This second minus first, fourth minus third, sixth minus fifth, and eighth minus seventh one. Such a way we are getting this part here. Similarly we prepare the column number 4, column number 5 we will prepare in the same manner. Add these two, get this value, and same way we follow this, and for this half part we subtract once again the same what we have done for this column. So after doing this 3, 4, 5 these columns, this G we are getting this first value as the grand total here. These are the corresponding values, these are the totals we are getting related to those treatment combinations here. So we are finding sum of squares here because we are having 24 observation. So we'll have here divisor as 24. So G square upon N means this square divided by 24 will get this as the correction term or correction factor. This square means this square divided by 24 will get this one. Similarly for the remaining, and which treatment combinations they are confounded related to that we are not writing here sum of squares here. So see here in the first replicate observe this one other than 1. So we are having N and P are the single factor. So NP confounded in this first replicate. Here other than 1 we are having this NK gets confounded in replicate 2, and in third replicate other than 1 we are having this block 2, PK gets confounded in the third replicate. So this NK, NP and KP these are confounded in the 3 replicates. So because of that we are not having this value, we have not calculated. Other than those values whatever sums we are having, those sums its square divided by 24 we got this sum of square related to those treatment combination. Then calculation of sum of squares due to confounded effects, same as like in the previous practical we will obtain for this here. So we got this block totals once again for obtaining the block sum of squares. Like in the previous case we'll get total of this squares of this sum of totals here. So we'll get this related to the summation Bj square, actually this we are having. Then treatment combinations NK, NP, KP where they gets confounded. NK confounded where it is confounded in the second replicate. So NK confounded in the second replicate. In the first replicate NP confounded, and in third replicate KP confounded. So those we have written here which confounded where NP and KP confounded in 1 and third replicate. And accordingly, in the previous case we have done this same we are doing here also, only what we are doing this while obtaining sum of squares here. In the previous case we have divided that by 24 here. Whatever factorial effect total will get by sum from the table we are having, means this from the table we are having related to nk minus 25, np 35 and kp 31. This value we have substituted here, 25, 35 and 31 here, and from this we have subtracted the adjustment factor. So minus 25 minus minus 20, so it becomes plus 20. We are having minus 5 here. 35 minus minus 32, so it becomes plus 32, so use 67. 31 minus minus 63, we are having 94 here. So we are having this as the factorial effect total. So square this, divide it by 16 only. We are having in all 24 observation, and this treatment combination gets confounded in one of the replicates. So because of that related to that replicate, we are losing the information for this treatment combination, so we are not including that here. So while dividing the square of this divided by the remaining, so how many replicates remaining? 2 replicates are remaining, from which we are getting the information related to this here. So those are 16 observations. So because of that we divide this square divided by 16 and we get this one. Similarly 67 square divided by 16 will get this one. 94 square divided by 16 will get this one here. So sum of square for all we are having here, and once again find out the total sum of square, double summation xij square minus ct, that we have done in the previous case. Everywhere we are finding this. Block sum of square, summation bj square upon 4 minus ct, that also we can have here. Treatment sum of square, addition of all this sum of square. Error sum of square can be obtained by subtraction. Total sum of square minus block and minus treatment sum of square that we subtract, and we get this as the ANOVA table here. Total 6 blocks, so we are having degrees of freedom here 5. Treatment 7 we are having, so gets divided into 111 here. 23 total degrees of freedom, because 24 observation minus 1 we are having 23 degrees of freedom. 23 minus this 12 will get here 11 degrees of freedom, and corresponding sum of square we have written, means sum of square we have obtained here. F ratio we have obtained once again. If it is less than 1 we will take 1 upon f there, only that will have obtained here only. In this case we are having 1 upon f only. Everywhere we have obtained f, but in this case we are having this is less than this here, so here only we have obtained 1 upon f, and the corresponding for the corresponding degrees of freedom f table values are also here given. So check here whether accepted. Here this is accepted, 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 here also accepted. Everywhere we have accepted the null hypothesis for treatments also and blocks also. So from that we have taken written here conclusion H0 B. For this we are having b1 equal to b2 equal to b6 equal to 0, and h1b we are having blocks differ significantly. Statistic we are having f phi 11, that value we are having phi 11. Wait for a minute, we have taken I think here, yeah, here just see here, this is 140 and here 146, so this is less than this here, so we have taken 1 upon f. 146 divided by 140, that we have taken. So because of that we have taken here this degrees of freedom reverse here. In place of phi 11 we have taken 11 phi, this value. Okay, this follows phi 11, but we have taken reciprocal, so because of that we are having 11 phi. So here we are getting MSC less than MSB, so we have taken 1 upon f. F we are having this, since f calculated less than this we accept H0 at 5% level of significance, that is blocks do not differ significantly. Similarly for all the treatment combinations we are accepting the hypothesis, that also we have seen. So we'll write here all treatment effects are insignificant here, they do not differ significantly, that also you can write. And this is the second example related to the same pattern example only you have to solve here.